If you're watching this far, we're partway through a question. You also need to go and see the first part. We've got to the point where we've got an unknown n, we've got a p-value and an r-value, we've got a formula here, and we actually know the answer we need is less than 0.01. So we're going to put in what we know. N, choose 0, p to the power of r, 1 minus p to the power of n minus r, and that has to be less than 0.1. Anything choose 0 is 1. That's a result you can learn and use. Anything to the power of 0 is 1. So here, actually, I'm only getting anything from this bit here, 0.4 to the power of n. Left-hand side is just that. And I've got to have this less than 0.1. Solve this equation here. Two ways of doing it, and one is trial and error. When n is 1, 0.4 to the n is 0.4. When n is 2, 0.4 squared is 0.4 times 0.4. That's 0.16. We're trying to get this to be less than 0.01. Well, it's not at the moment. When n is 3, times it by another 0.4, I get 0.06 something. Still not smaller than 0.01. Do it again, times it by another 0.4, 0.02 something. Not yet small enough. Another 0.4. I get 0.0102. It's not yet smaller than that. When I do another 0.4, which will be 0.4 to the power of 6, I get 0.0041. Now n is 6. This number is smaller than 0.01. So the n, the number I was looking for, the answer for this question is 6. There is an alternative way of solving equations like this. It's not on the AddMaths syllabus, but it's a shortcut, and if you remember it, that's great. And I'm not going to explain at the moment why it works. But if you get this, you use a log button on your calculator, and you do log of the number without the power. Then you divide by log of the number with the power. So if I'm doing that on my calculator, I'm doing log 0.01 divided by log of 0.4. That gives me 5.02. So n, the number I'm looking for, has to be at least 5.02. Well, in this question, it's got to be a whole number. So the first whole number, at least this size, is 6. So that avoids you doing the trial and error.